Okay, so the last objective is kind of going the opposite direction. So we're going to use the linear factorization theorem to find polynomials with given zeros. So instead of given the polynomial, we have to find the zeros. Now we're going to be given the zeros, and we want to find a possible polynomial. So remember we said that anytime you have something that is a zero, then you can put it, so let's say k is 0, then you know that x minus k is a factor. Because remember, we get the k as a 0 by setting this factor equal to 0 and then solving for that, right? So in the practice today, sometimes you're going to have to kind of go backwards from this. You're going to say like x equals whatever the 0 they give you, and you can work your way backwards until you have something equals 0. But for the examples we have here, like in your My Math Lab, it might not be quite as complicated as on the practice. But one other thing you should remember before we get to 4a, sorry, and it is mentioned in your notes, that if you have complex roots, remember they always come in pairs. So if you have a complex number, so like a plus bi, if a plus bi is a factor, so is its conjugate a minus bi. So if it's listing zeros, it'll probably only mention one of them. But if you know that it has one of them, you know it has to have the other one as well. So looking at 4a. We want a fourth degree polynomial function with real coefficients that has -2, 2, and I as zeros. And we also know that f of 3 equals -150. So the zeros we have 2, -2, I. And because we have this one, we know we have the conjugate, which means we're going to make the imaginary part negative. So we also have a -I. So we have 4 different zeros, and it is a fourth degree polynomial. So that means we don't have any multiplicities, which is good. And we also know that f of 3 equals -150. So first we're going to put in all of these zeros as factors, and then we're going to use this fact to figure out what your a is. So remember, when you're trying to solve something like this, let's say this is how we've all factored it out. This 3 really doesn't make any difference when it comes to finding the zeros. So when we're trying to go backwards, we have to use this to help us figure out what that 3 is. Now in the practice today, the a is always just going, not necessarily always going to be 1, but I'll do an example video for that. So you'll just have to look for that. Okay, so back to this example. So we want to set these up as factors. So if x equals 2, that means x minus 2 equals 0, which means this is a factor. Same thing here, if x equals -2, then x plus 2 is a factor. Now for this again, so it's x minus my 0, so x minus I, and then x minus -I, which means plus. Okay, so I know that my polynomial f of x is going to equal all of this times some constant a. So we're going to kind of ignore the a for the moment, and we'll figure that out later. So what I'm going to do is I'm now going to put all this together. So what I'm going to do is I'm going to multiply these two together, and then I'm going to multiply these two together to try to make it a little bit simpler. So I have x minus 2 times x plus 2. So we have an x squared. My plus 2 and minus 2 middle terms are going to cancel. Notice this is like the setup for the difference of squares. So this becomes x squared minus 4 for that one. And then for these two, again, we have a plus I, or a negative I plus I, so those middle terms are going to cancel. So we're left with x squared minus I squared times some constant. So x squared minus 4, remember I squared is a negative 1, so this becomes x squared plus 1 times some constant. So now if I multiply these two together, x squared times x squared is x to the 4th. X squared times 1, negative 4 times x squared, and negative 4 times negative 4 times positive 1. And combining like terms gives me x to the 4th. 1 minus 4 is negative 3x squared minus 4 times some constant. Okay, so I've taken care of all the zeros. I'll put them all together back into its original polynomial. So now I just need to figure out what my constant term is that I'm going to multiply it to get the value I want. So I know that f of 3 is equal to negative 150. So that means my answer is going to be negative 150. And when I put in a 3 to all my x's, that's how I get it. So I'm going to put in that 3 to my x's. So I have 3 to the 4th minus 3 times 3 squared minus 4 times some constant, and that should give me negative 150. So negative 150 is going to equal 3 squared, 9 times 9, so we have 81. 3 squared is 9 times 3 is negative 27 minus 4. 81 minus 27 minus 4. 81 minus 27 is going to be 64. I don't have my calculator on me. We'll say 27 minus, that's negative 31. So 81 minus 31 is going to be a 51 times A. I'm sorry, that's 50. I don't know why I put the 1. So 81 minus 31 is 50. So negative 150 is equal to 50A. So we divide both sides by 50 and we get a negative 3. So A is going to be a negative 3, which means my f of x is going to be negative 3 times x to the 4th minus 3x squared minus 4. Distributing that all out, we get a negative 3x to the 4th plus a 9x squared plus 12. Okay, last example, 4b. We want a 4th degree polynomial with real coefficients that has zeros of negative 2, 5, and 3 plus 2i. And f of 1 is equal to negative 96. So again, if we know that 3 plus 2i is a 0, we know that 3 minus 2i is a 0. Putting these as factors, you know my f of x is going to be x minus each 0. So x minus a negative 2 gives me a plus 2. X minus 5. X minus this 0, so we have a negative 3 minus 2i. And an x minus 3 plus 2i. And that is going to be multiplied by some constant a. Okay, so if we multiply all these together, x plus 2 times x minus 5, we have x squared, outside negative 5x plus 2x minus 10. This one we have x squared. Now this one, because there's 3 terms, we're going to multiply this x to all 3. So we have x squared minus 3x plus 2ix. Multiply the negative 3 to each, we have a negative 3x plus 9 minus 6i. And multiplying the negative 2, so we have negative 2ix plus 6i minus 4i squared. Okay, Alright, simplifying everything, I have x squared, negative 5 plus 2, negative 3x minus 10. Okay, so we have 1x squared. Now we have a negative 3x minus 3x gives me negative 6x. Now we have this plus 2i minus 2i, so these cancel. I'm looking at the odds of plus 6i minus 6i, so those also cancel. And so now we have a 9 minus 4i squared, or plus 9 minus 4i squared is negative 1. This becomes a plus 4 times a. So we have x squared minus 3x minus 10 times x squared minus 6x plus 13 times a. And now we have to multiply again. So now we have this quadratic times this quadratic. So again, we're going to take this first term, multiply to all three, second term, multiply to all three, and the third term, multiply to all three. So x squared. So we have x to the fourth minus 6x to the third plus 13x squared. Now it's negative 3x, so we have a negative 3x to the third plus 18x squared minus 39x. Now the negative 10, we have a negative 10x squared plus 60x minus 130, and all of that is multiplied by. Okay, combining like terms, there's only one x to the fourth. Now cubes, we have a negative 6 minus 3, which is a negative 9, and that's it. Now per squared, I have a 13 plus 18, so that's 31, minus 10 is 21. Now for x's, we have a negative 39 plus 60, which is a positive 21. And then we have a minus 130, all times a. Okay, so it's going to be this polynomial times some constant. And I don't want to put in a 1 into x, I should get a negative 96. So I have a negative 96 is equal to 1 to the fourth minus 9 times 1 cubed plus 21 times 1 squared plus 21 times 1 minus 130. So I have a 1 minus 9 plus 21 minus 130. So if I add all the positives together, that's a 42, 43, minus 9 minus 130. So 43 minus 139. And that gives me a negative 96. So I have negative 96a is equal to negative 96, which means a is equal to 1. So my f of x is just my x to the fourth minus 9x cubed plus 21x squared plus 21x minus 130. And that is it for 2.6.